There you go. Right? No, I'm good with this. So this is sort of focusing the light on me, and I can't see anything of the audience, so excuse the kind of interaction that will go along as we talk. I want to keep it a bit brief, and I want also to spark some ideas regarding the criticality of water in the Indian context, and some response which comes from the city where I live now, Bangalore. And the first and most important point that I want to make to you, to think about water when we think about India, is to remember the fact that we are a groundwater civilization. We are the world's largest user of groundwater by far. China and the USA put together do not use as much water as India does. The numbers are there before you. 85% of our drinking water needs, rural and urban. Urban India depends on the groundwater to the extent of 50%, urban India, and rural India is 90%. So overall, 85% of our drinking water needs, domestic water needs, 60 to 65% of our total water requirements, including for agriculture and industry, comes from groundwater. And this is crucial for us if we want to design sustainable systems around water. Because it starts way back from the Indus Valley civilization, which is the culture of the well. Mohenjo-daro, Harappa, Lothal as this well, 2900 BC, 2300 BC, up to 1900 BC. Though called the Indus Valley civilization, the fact is that these people drew water, and this was an urban civilization, mind you, that these people drew their water requirements from wells. And it's legendary, everybody knows in the Indian context, students know especially, that we had excellent drainage systems there, and that now we have to go to a Swachh Bharat to recreate what the Indus Valley civilization had done. Most importantly, wells were the source of water then. Wells and bore wells continue to be sources of water for us now. So if you come to Sarnath, where the Buddha gave his first pravachan, his first preachings to his disciples, Sarnath is near Banaras, Varanasi. Sarnath does not have a river or a lake. Sarnath has a well, a series of wells. This is where the Ashoka pillar came from. Sarnath has this particular well. The well has water, and the water is sweet. So are we privileged to be drinking the same water that Gautam Siddhartha drank? Are we blessed to not only listen to his spiritual sayings, but also be part of the endeavor of accessing good, clean water that the Buddha was part of? These are the kind of sustainability ideas around technologies, around artifacts, that we need to remember that we have in India. And when we design sustainably, can you think of anything sustainable for 2,500 years? Because we are talking about 260 BC, right over here. Because with water, the crucial point that I want to make, A, that we are a groundwater civilization, B, we need to talk and listen to the resource called water. And the open well is a great communicator. It not only is functional in terms of giving water to us, but it talks to you. It tells you when summer is coming. The water levels go down, you have to change your behavior to the availability of the resource. Come rain, the water comes up, so you're entitled to more of the resource. There's a constant communication, and that breakdown in communication in terms of the design fabric of our cities, of our settlements, of our houses, is one part of the problem of not being able to manage water sustainably. Here is this particular artifact, and the more I look at it, the more fascinated I am, because if what we call science, which is codified knowledge, has developed, perhaps it's hydroscience that was the first science. The well liberated human beings from the tyranny of rivers and lakes. Till you discovered that a hole in the ground could give you water, you had to stay near a freshwater source, which is a surface water source. And somewhere along the line, old human beings, 9,000 BC is the oldest well dated that we know of archaeologically, found that a hole in the ground could yield you water. And this was tremendously liberating. It allowed you to go into the countryside and occupy it. And around it developed the knowledge of where to dig for a well. You started to understand the landscape, the rocks, the soil structure, the flora, the fauna, especially trees, and then you knew where to dig so that you had a good chance of finding water. And that codified knowledge translates itself even now. So science, one argues, develops around wells. And wells reward you is also Zen. It tells you that if you do the good things, like recharging the aquifers, it rewards you. And then you can sit in the evenings enjoying what you have to. And it punishes you. If you overuse the water, if you put polluting materials nearby, the water is contaminated and you cannot use it. So there's a philosophical argument around the shallow aquifer and the well that we need to integrate into our current societies and resilient cities. Because wells are not only about science itself, but also technology. I don't know, some of you would know this. I'll try to play this video. If I can get some help on this video, can I sort of request you to tap on? Technology is science in action. And what's happening with technology is that you need to raise more and more water. So there develops the pulley, which is using a rope, and then the pulley becomes the Persian wheel. And I'll try and see whether I can get this video going. Perhaps show it around. Let me just ask, can I just get this video playing? You'll have to do it here, I guess. Yeah, but you'll have to come in here and tap. Can I get this video to play? Okay, so let me come back to the video because I'll talk about visibility and invisibility as we go along. I'll get back to the video and show you how we have changed our way of looking at water going along. But then, let me also talk about my city because it was in the news for the Kaveri Tribunal yesterday, and we had a problem which went to the Supreme Court and which got resolved. But here's typical India, and this Indian city called Bangalore sits with 11 million people, 1,250 square kilometers area, sits on a ridge line, 920 meters, and is dependent on a single source called the Kaveri. There comes the challenge. How do you create resilience when your source of water is only one? And this is the city in a river basin. So when we design resilient cities, we have to imagine ourselves hydrologically, place ourselves in a river basin and see how sustainable we are vis-a-vis the river basin. It cannot be the city itself which talks to its own waters. It has to talk to the river basin. And there are 4 dams upstream of the city of Bangalore, 4 dams in various districts on the Kaveri River. And all 4 dams play themselves to provide water to the city. The operation of these 4 dams work around provisioning water to the city first. Then if there is surplus water, that is used for agriculture, and if there's further surplus water, then it goes for industries. That's the kind of dependency we have created, that entire river basins have to move to feed water to a city. And here in this particular case, the Kaveri Basin waters are completely utilized. Not a drop of water, river water reaches the sea, except during heavy rainy seasons. And even that water is exhausted, therefore the city has to think of going to another river basin 320 kilometers away to get water. The one other option before it is, can it go local? Can it do rainwater harvesting? Can it do wastewater reuse? And can it do demand management? This local versus the far away is the constant tension under which cities work. And meanwhile, the city itself urbanizes, destroys green cover, destroys wetlands and lakes, prevents recharge by crusting, and I'll come to that, has intense rainfall events due to urban heat island effect, floods, urban flooding is a new phenomenon, and of course pollutes streams and lakes and groundwater within itself. And this is a map which Dr. T.V. Ramchandra from the Indian Institute of Science shows us. The red is the increasing concrete cover, and the green is the disappearing tree cover. And you see that we're just simply knocking off trees and nature as it exists in the city. And in this context, we have to start to manage water. So, what the city has done is to work around rainwater harvesting from individual homes. You start with the smallest unit, which is a home, and you look at the hydrological cycle in this home, right? What happens to the hydrological cycle on a 150 square meter plot area or site area? And I'll give you the numbers. If the site is unbuilt, and those are the figures on the left, the surface runoff is between 10 and 15 liters, or 10 and 15%. Recharge, which goes to the groundwater, is between 8 and 10%. 75% of the water stays in 1 meter of soil and evapotranspires. The moment you build on it, The runoff now goes from 15 to 90. Actually, it goes to 100. So you've increased runoff from a site 6 times or 7 times, and then, therefore, you're left with urban floods and you're left with no recharge. How do you reverse it is the basis of policy, bylaws, and design. And how you do that is by putting up forward a law which says that for every square meter of roof area, the plot has to get responsible for 20 liters of rainwater storage or recharge. And for every square meter of paved area, you have to become responsible for 10 liters of storage or recharge. And when you make the recharge structure on the plot, you have to make sure that it's about 3 meters so that it bypasses the clay layer and actually gets into the aquifer. Simple policy bylaws can follow from understanding hydrological cycles at a site level. And easy ways of harvesting rainwater, I don't have to show it to you. We have, I think, about 100,000 rainwater harvesting systems in Bangalore. The number can get even bigger. Is to stock up in rain barrels as such. And then you move from the individual house or site to what we call layouts. These are essentially gated communities. And what do gated communities do? This is the design challenge for water. How can we convert water from an individual resource, a private resource, where everybody can sink a borewell and draw water, competing with the other? For example, in this layout, 360 plots, not connected to the city utility. So you would have had 360 straws, 1,000 feet deep, borewells, taking water out from the same bottle, competing with each other. How do you reverse the process? The process is reversed by turning water, groundwater, into a common pool resource. And what does a common pool resource mean? It means that no individual can sink a borewell, that the community sinks 3 borewells and supplies whatever water is there in the aquifer to everybody. Share that equitably. Then, each one of the community members, those are the 360 lots, take responsibility for recharge. So each one of them picks rainwater and puts it into the ground, adopting the stormwater drain in front of it. And then, what you then have is sustainability. Through demand management, you put a price on water and make sure that that every family does not get more than 20,000 liters of water. Pricing is crucial. Demand management is crucial. Understanding the hydrology is crucial. Recharge is crucial. And communitizing the resource is crucial. Private market forces cannot lend themselves easily to sustainability. And then you can recycle the wastewater, which the layout generates at decentralized wastewater treatment plants, and reuse it for non-potable water use. So this, at units of 36 acres, 70 acres, and 100 acres, eventually perhaps the city is our aim. Or for example, this 70-acre gated community, where you had this huge well, and because the community was not aware of the possibilities of shallow aquifer, it had done nothing about it. But when they became aware, they cleaned 120 truckloads from this well, as you see on the left. And this well alone provides them all their water requirements for about 6 to 8 months, a 70-acre community. So understanding shallow aquifers, understanding rainfall patterns, understanding recharge rates and percolation is crucial to getting sustainability going at slightly larger scales. And then you come to the city itself, 1,250 square kilometers, that's the planning area, divided into 3 major valleys. And one of them I show you on the right, which is the lake system called the tank system. The tanks were created for irrigation purpose long back, 500, 700 years back. Each tank or lake overflows to the next one. It's connected by a channel. How do you rejuvenate these tanks in a modern context where the irrigation needs have disappeared? When you're confronted with the fact that there are many departments of the government dealing with it, and this is just a sample, there are at least 14 departments of the government dealing with one lake or tank. So the crucial coordination comes from citizen groups. Citizens groups who adopt the lake and do the nodal coordination with each department. So if it's sewage, you go to the water and sanitation utility. If it's garbage, you go to the local government, the Mahanagar Palike or the corporation, and so on and so forth. So that nodal coordination and creation of the group becomes crucial. And then the design kicks in. How do you do the design? See the figure on the right. A conventional wastewater treatment plant or a sewage treatment plant, 10 million liters per day, followed by a constructed wetland. So the water is further polished once it comes out of the wastewater treatment plant, and then it goes to the lake. And the lake then allows for fishing to happen. Remember, crucial to all this is not the technological knowledge, but how do we keep it financially viable. A sewage treatment plant is financially a sinkhole where you're just putting in money and you're not getting returns. But if you can convert the ecosystem for it to become remunerative, then perhaps you have a sustainable system. The fish in this case can pay for the running of the sewage treatment plant. The challenge is, how do we design the institutional architecture to make sure that livelihoods are supported by the fishing, and that the fish, the monies and the profits generated by the fishing activity actually goes towards running the sewage treatment plant. You'll notice also that a sludge truck is coming to the bottom left. This one truck comes every 2 days and it sells for 10,000 rupees. And the manure is excellent for farming and cultivation, provided it is free of heavy metals. We need to keep that check in mind. But there are ways by which we can organize wastewater treatment systems with ecosystem design to make it financially viable. And then the benefits are that it recharges groundwater, and this well, for example, is now recharged actually from wastewater by removing the yuck factor, going through a wetland, going through a lake, percolating down, coming into a well, and by this time the water is good enough to drink. And there's no psychological barrier for it. So this lake, which I showed you, called Jagkur, can recharge about 7.5 million liters per day, 7.5 million liters. At 100 liters per capita per person, it can provide 75,000 people with water, and it's actually wastewater converted to drinking water. So these are the systems by which we want to take it to further lakes, and today we are inaugurating another project of the same nature, 10 million liters per day, which can replicate itself across not only Bangalore city, but across India, where you link lakes, wastewater treatment plant, groundwater, and drinking water potential. Sludge from the treatment plant, as you see here, is excellent manure for the crops, so it provides livelihoods for farmers who surround the hinterland of a city and who therefore can earn a livelihood from it. So the design challenge for us is more the institutional and governance architecture challenge. The coordination challenge, getting people to talk to each other and institutions to talk to each other and designing systems that work continuously, because it's easy to design a system but difficult to make it run. Especially Bangalore city has lakes which catch fire, which foam, so there's a negative press all about it. How do you get the positive stories to roll themselves out more is also a big challenge. And replication. So replication means once you do a good design, you take other members, communities, show them, and make sure that it gets translated to further action. It's not about scaling a project by one institution, it's about replication by many communities. So it's a million solutions rather than one big solution, how we go about it. For example, you see that the fisherman is a key stakeholder who makes sure that the water hyacinth is removed once every month. Once the fisherman becomes part of the solution space, then you get the lake to be cleaned and maintained. And so this wastewater can then be converted to a resource and lakes can be protected. So I think water sustainability in urban India will come by a combination of using rainwater, sewage treatment plants, lake rejuvenation, and groundwater, which is called water-sensitive urban design in Australia, which I'm sure you'll see examples of, or integrated urban water management as a design concept. And as designers and as architects, we have to think of the entire ecosystem, as I mentioned to you, the legal framework, the ecological paths, the thinking from linear to circular at city scales, and the setting of good examples and getting communities to own such solutions. This is what I had to share with you. I'm there up on Twitter as Zen Rainman, Facebook as Zen Rainman, YouTube as Zen Rainman. So if you want to get in touch with Zen Rainman, tweet. I'll be happy to respond to you and carry the conversation forward. Thank you for your patience and time. I've been told by the organizers that I can take a couple of questions or a couple of comments and listen to them. So happy if anybody wants to be bold enough to raise their hands and speak. Oh, there you go. Sir.
Yeah, we'll just have the mics.
Yeah. Yeah.
We'll have our volunteers give away the mics. Just a minute.
I think firstly I want to say, Vishwanath, that it's a fantastic and relevant presentation you made, and I came in the latter part of the presentation, but whatever I got out of it was so valuable. I just want to make a couple of points which raise questions. We confronted with this idea. I come from a city of Baroda where we've done studies on vanishing waters and lakes and whatnot. But bylaws are there for, harvesting water for gated communities as well as private properties. But what is happening, we're facing that problem is that water is available for charging only in the monsoons, those 3 months of heavy waters which are there. In that phase, the water tables have already risen in many parts. So recharging actually is not working very effectively. That is what we've seen. That is one problem. The second thing is on private borewells, there's no regulation at all. And the bigger the garden, the number of borewells you want to bore in. So there's no regulation and policy, at least in our city. And the third is regarding this interlinking of lakes. Like in a city like Baroda, a lot of lakes are contaminated because of industrial effluents which have got into lakes. And a lot of groundwater is also polluted because of industrial waste and water which is just discharged, So that is a very big problem we are facing. And there is also a problem of this water hyacinth which has evolved in all these lakes, So interconnecting is another big issue because the moment you start linking one water to the next, you're actually transferring all the problems of this water body to the next one. These are some of the problems. I hope you can share some.
Yeah. So very quickly to respond for the first nice comment, the beer is on me in the evening for being very positive about it, but that's being a bit fatuous. So let me get to the serious parts of it. These challenges are typical for every city. So what we try and do in Bangalore is to pick a lake or a tank which has a reasonable chance of being rehabilitated. Work from the ridge, the topmost lake, and then work your way down from the one which is not contaminated industrially, and so on, and you begin. So the water hyacinth was a big problem here. The fishermen started to clean it up, and now the fishermen keep the water hyacinths away. Water hyacinth in the wetland is fabulous in removing heavy metal and nitrates. So you need water hyacinths, but you don't need it to overrun the lake. How do you draw the balance and keep it going? Seems like the fisherman is very good at it. Rainwater harvesting, the challenges are very local, very contextual. One has to work at the aquifer and the rainfall pattern to make sure that you're able to grab as much of it as is possible. So perhaps the aquifer has to be depleted during summer months, kept ready for it to be filled up to the extent possible during the rainy months. And you do that as a supplement, not as a complete replacement for alternative sources. So these are not easy questions to answer everywhere. Borewell regulation, we found it extremely difficult because even in our city, borewells are not regulated. But we found that gated communities, associations, can actually ban private borewells. And they did a social banning too by stopping the truck which brings the rig to drill from the gate, at the gate itself. And then pretty soon people understood that everybody would benefit if you actually stop private borewells. So that kind of an understanding and flipping takes time. Let me tell you that the example of the gated community took us 8 years. The lake has taken 12 years for it to revive. These are the kind of time scales that we talk about. But we have to start to build on the momentum. And I completely agree with you, these challenges are enormous. Yeah.
Good morning, sir.
Yeah.
I have one observation and one question. So yesterday, someone came on stage to speak about how nature is a non-linear system and how that means that you can't always correlate the actions that you do to the results that will come from them. And I believed what they said yesterday, but then what you showed us with Lake Jaggu today, I think I've changed my perception from yesterday because it seems like it just takes a little longer to show the linkages from action to result, but it is possible to show it. So that was one observation that I wanted to share from what I learned yesterday. And for the question that I had, you spoke about how people need to understand shallow aquifers and rainfall systems. And only when they understand it will they be able to take the steps which are necessary to create a more sustainable system for themselves. But this kind of information, as an architecture student, I've been trying to find this information for the region that I'm planning for or designing for. And I don't know the kind of resources that are available to gain such information. So could you tell us something about the resources where we could tap into for this information?
Yeah, so that's a very important and interesting question. The resources come from the Central Groundwater Board and in Maharashtra, the GSDA, the Groundwater Survey and Development Authority, GSDA. Both are excellent institutions which put a lot of information in the public domain. So it could be a start and a beginning for you to understand the hydrogeology and the aquifers. What I have personally found very interesting in Bangalore is that I've come across this community of well diggers. They're called the Wadders or Ode community. They've been digging wells in India for 1,000 years. And I find them still earning a livelihood in Bangalore by cleaning old open wells. And by working with them, I figured out and understood a map of the wells of Bangalore, and we have 10,000 open wells with water. In a city which believes that its groundwater has gone to 1,000 feet and 1,200 feet, these well-digging community people are able to identify localities and areas with shallow aquifers and good quality aquifers. So sometimes talking to the locals, understanding what's happening with groundwater in that area, and you have to have extreme patience to it, can help you get a lot more data. And I encourage you to have a lot more conversations in the areas where we design. Because I've seen designers in Bangalore, and we were just talking in the morning, who put a double basement in, pump water out for 6 months, good clean water, throw it all out and make it into a parking lot. I mean, these are the kind of bylaws and planning laws that we have, and complete lack of understanding of how precious that water is. How do we reverse it? It begins with each one of us individually for us to get enlightened and then to push policy in the right direction.
Also, I had a sort of weird question about the interlinking of lakes. It's not as simple as it sounds, is it? As in, it sounds like you're creating like a chain between them underground. Is that how it works?
So it's natural in Bangalore. What happened was when you had a valley, you threw an earthen bund or a dam across a valley and you created what is called a tank. Naturally, the water overflowed in the valley and went into the next tank. So it was naturally interconnected. We don't have to create the interconnectedness. Now what's happening is that those connectedness is being broken by real estate and people encroaching on these valleys, and that's a big challenge that's going on. But water will connect itself. Once you fill a lake and once you get it to overflow, it will find its way to the next lake. So how do we work around it? That's important.
Thank you.
Yep. Yeah.
If you could just speak a bit on the bylaws that have been implemented or that have been planned for the protection of wetlands, because especially in the case of Mumbai, when we were working when we were working during our thesis on research, we realized that either the bylaws are not present to protect them, or there is heavy relaxation in those terms for real estate to come into, because wetlands are not recognized for their importance as such. So if you could just talk about how they have been in Bangalore.
Yeah, so two quick points. One point about the wetland itself. It's not common knowledge amongst people that these tanks and lakes are actually wetlands. The imagination of the middle class and the designers is of a clean water body, something like a swimming pool. But these are palak soups of urban India. You know, these are nutrient-rich systems which grow a lot of macrophytes and hyacinths. And therefore, they're the easiest to manage as wetlands because they allow that flora and fauna to flourish. So wetlands is not understood by the laypersons. Come to the law. It took a group from Bangalore to go to the National Green Tribunal to demand the demarcation of these wetlands and a buffer zone. And finally, with the National Green Tribunal order, things are slowly and incrementally moving, very slowly. The state actually declared that it had no wetlands at all before the Supreme Court. Not till the NGT had to rebuke it and say, no, you identify these tanks as wetlands. So it's going to take a long time, and it's going to take a lot of civic activism and judicial activism for us to define those wetlands and protect it. Yeah, Prem.
We can take another question.
I'm just looking at the time.
As a person who made the point about nonlinear systems yesterday, I feel compelled to respond to, because I don't think there's a contradiction between what I said and what you said. And what I was saying, that in a linear system, you can draw a link between cause and effect at a theoretical level. But in a nonlinear system, it needs action on the ground. It's emergence, it's reading the signs. And what you said as well as communicator, it's learning that to have those kind of conversations. Then you move to harmony that way. So but our schooling tends to believe that that practice is just applied theory, and we first learn the theory, and in the theory we can draw the cause and effect diagram, and then we go and apply it in practice. So here, everything in a nonlinear system, everything has to come through practice, on action on the ground, listening to the ground.
That's absolutely what I would agree. A lot of time, you take what exists and learn to improve upon it, rather than to bring this ideal state to design and then try to see how the hell it fits in onto the ground. There's a huge difference between that, and thanks, Prem, for articulating it so well in terms of academically putting it together in such nice words. But the key is to begin. And the key is also to accept that you will never get the optimal, that you will be condemned to suboptimality, and to live with that suboptimality for yourself, though old monk helps once in a while on Friday evenings. But that's the way to go, yeah. Okay, I think if there is no urgent question, we can. Thank you very much for the time and patience.